The discriminant of a quadratic is the b squared minus 4ac part underneath the square root sign of the quadratic formula. This tells us something about the nature of the roots of the quadratic. The roots are the solutions to the equation. If b squared minus 4ac is greater than 0, the roots are real and different. Sometimes they're called real and distinct. If b squared minus 4ac is equal to 0, the roots are repeated, or equal. They both have the same value. And if b squared minus 4ac is less than 0, the equation has complex roots. So how does this look like on the graph of the quadratic? If b squared minus 4ac is greater than 0, we have distinct roots. So that means that the graph is going to cut the x-axis in two distinct locations. In all of these sketches, we'll use the coefficient of x squared a is greater than 0, so we'll have a valley-shaped graph. In a case where b squared minus 4ac is equal to 0, we have equal roots. So that means that our graph will just touch the x-axis. So we will have our repeated or equal roots occurring at this point. If b squared minus 4ac is less than 0, we have what are called complex roots. There's no real solution to this equation, and it won't intersect the x-axis. Let's have a look at a different problem. Given that x squared plus 3 plus k x plus 1 is equal to 0, find the values of k such that the equation has equal roots. Well, for equal roots, we need the condition b squared minus 4ac is equal to 0. The b term is equal to 3 plus k. It's a coefficient of x. A is equal to 1 and c is equal to 1. So for b squared minus 4ac is equal to 0, we can rewrite this as 3 plus k all squared minus 4 times 1 is equal to 0. Expanding the bracket, we'll have 9 plus k squared plus 6k minus 4 is equal to 0. Rearranging that, we'll get k squared plus 6k plus 5 is equal to 0. And this will factorize nicely. K plus 1, k plus 5 is equal to 0. So therefore, k is equal to negative 1, or k is equal to negative 5, are the two values that will give the equation equal roots. You should now attempt the multiple choice question.